When it comes to prime factorization, it's really a tool that helps us to reduce fractions, and we'll be playing that here in just a little bit. So the thing we want to focus on is being able to prime factor a number. In order for it to be prime factored, it has to be a composite number, and prime numbers are your numbers, well, a number such as 11, come on, there it goes. A number such as 11, 17, 23, which are numbers that we can only the product of what is 11. Well, the only two numbers multiplied together to give you 11 is 11 and 1. 17, there's no two whole numbers multiplied together to give you 17 other than 1 and 17. Same for 23. 100 is composite because if we look at 100, we can say, okay, that's really 2 times 50. So looking at it as 2 times 50, we could say, well, the 2 can't be broken down, but the 50 can be broken down again as being 2 times 25. So looking at it now as 2 times 2 times 25. Well, 25 is still not prime because we know 25 is 5 times 5. So the 2 with me one more time, bringing on down 2, and then now I'm left with 5 and 5. So prime factoring 100 is a list of primes known as 2 times 2 times 5 times 5. And these are arranged in the appropriate order because I have the 2's grouped together, the small, and the 5's grouped together in the top. So we could set 100 equals 2 times 2 times 5 times 5. So similarly, breaking down 110 might be something that you say, hey, that's 11 times 10. Okay, now the 11 is prime because that's all that we can do with 11. We can't break it down any further. But the 10, just like we've done in the past, say the 10 is 2 times 5. So now I've got 11 times 2 times 5. While this is the list of primes, our best answer is going to be listed as 2 times 5 times 11 because the prime's listed in order. So 2 times 5 is 10, 10 times 11 is 110.